Everybody, we are Group B, a technological company hired by a cryptocurrency broker to develop a real-time control center based on the Binance API connector that they will use to see the crypto balance account portfolio, the bid and ask volumes, and the buying and sellings of the market. In the next slides, before going diving in our objective, we want to clarify with you that our target is just to show the relevant information to our investors. And this is an example of our dashboard project. Right now, Sebastian is going to continue talking about the end-to-end big data architecture.
Thank you, Tony. So just going through an overview of our big data architecture. It begins with Binance, where we take our data in motion. From them, we are streaming two WebSockets, the mini ticker and the market depth. Then, using Kafka, we produce a Kafka topic for the streams that the data will be processed in the next stage. Then, using PySpark, we consume from the Kafka topic and we process the data. We also join the data with data at rest, which is coming from a CSV file that has the account number and the account balance for some of the customers. Then we prepare the data for MariaDB and we insert the data in MariaDB into a table. Finally, using Superset, we read the data from the table in MariaDB and use it to create our dashboard. So on the next slide, I'm going to show you a little bit about the WebSockets that we are using from Binance. The first stream we're looking at is the mini ticker, which is on your left. It is summarized information of a given ticker, like candlestick prices and volumes, that is pushed every second. The second stream we are going to look at is the market depth, which gives the price and volume for both the bid and the ask side of the top 20 quotes in the order book and is pushed every second. Now, Paula will talk about the mini ticker producer.
Thanks, Sebas. So in order to subscribe to the different streams and get the necessary data for our business case, we developed two producers. So the first one is the mini ticker producer. You can see how we first subscribed to the mini ticker streams specifically for the Bitcoin and Ethereum cryptos. So as Sebas mentioned before, this stream allows us to get the information regarding the prices and volumes of the different cryptocurrencies that we will be using. Then the second step, as shown in the right part of the slide, is to parse the data and send to the Kafka topic the desired variables coming from the mini ticker stream. Now, Fernando will continue explaining the mini ticker consumer.
Perfect, Paula. For the consumer, the main function starts by creating the sparse session and reading the initialization configuration file with all the credentials. Then the code enriches the data at rest with data in motion with the inner join, and grading the data into the for each batch function. As we can see in the next slide, in our data frame, we casted all the variables into the correct data type in PySpark and added the processing timestamp. Also, we included and established a watermark of 10 seconds for our tumbling window, grouping by symbol and the processing time and aggregating the volume and quote. In the next slide, the mini ticker consumer will first establish the connection with MariaDB by using the override mode. We decided to use this one because as we use key parameters that could repeat over time, we had the risk of crashing the consumer appending this information. The consumer selects 9 fields that includes calculations regarding the cryptocurrency that is processed. In the next slide, here we have the PySpark application consuming from Kafka, enriching events with reference data and displaying them in the screen. Now back to Paula.
Thanks, Fer. So moving on to the next stream, we generated the depth producer. Through the parser argument, we're getting the broker and the topic names to define the parameters where the events are going to be stored in Kafka. So as we can see, with this producer, we're subscribing to the depth stream and the Bitcoin and Ethereum cryptocurrencies. In the next slide, we can see how we use the auxiliary function to parse the stream from Binance into Kafka for the depth topic with a string of arrays formats. Through this auxiliary function, we're able to define the parameters coming from the depth stream and generate the WebSocket. And now Nico will continue explaining the depth consumer.
Let me jump into the depth consumer application explanation. As you can see, the first thing that we do is to read again the configuration file in order to get the proper Kafka topic to subscribe to. After that, we create a Spark session that we will use throughout the process. While reading each event from the input source defined as Kafka and splitting them with a pipe delimiter, each time we convert it into the proper format. The tricky part here is that the asks and bits are coming on a string format containing arrays of arrays. Therefore, we need to rely on the from JSON method that will help us convert each column into the arrays of arrays. In here, as we did in the previous mini ticker consumer case, we are including as well the current timestamp and processing timestamp coming from Binance, which is in a millisecond format and needs to be reformatted. But what we are not doing here is any other processing related to asks and bits, as we will be relying on the for each batch function to complete the volume of order calculations. So in the next slide, we see how we send it to the for each batch function. And then on the following one, what we do is create a pandas data frames after exploding the array of bits and asks separately. So in the for loop, we are generating 3 lists: the symbol, a string, the timestamp as a timestamp in timestamp format, and the product of the converted bit quantity and bit price. Once the data frame is created, the same operation is performed with the ask variable that is shown in the next slide. And finally, we do a merge to create a combined data frame. That is that we can see that in the next slide, how we perform the merge. And finally, once that's finished, we convert it into a data frame into a PySpark dataset, and we send it to MariaDB. The final variables stored are, as you can see there, the symbol, the timestamp, the total volume bit, and the total volume ask. Now let's go with Akash, who's going to explain us the MariaDB structure and how we load everything in Superset.
Thank you, Nico. As my colleagues explained before, we're storing all this information in MariaDB. And here we can visualize the database's structure of the depth and quotation tables created. Now that these databases are established in MariaDB, now we can go live with the databases to Superset. Right, so Superset is an easy-to-use business intelligence tool that collects and processes data in large volumes to produce visualized results like charts and graphs. Thus, we're able to generate dashboards for our business case, which is to allow Binance users to track their cryptocurrency balance and within the portfolio and bids and ask volumes for the different cryptocurrencies within that portfolio. So on this dashboard, we can visualize different metrics from the depth and quotation databases created and shared to Superset from MariaDB. And the data is refreshed every 10 seconds within this dashboard. So this dashboard contains metrics such as the crypto balance and by account and currency, which is the total amount of balance of each account and the different cryptocurrencies within that account. This metric is directly calculated from the quotation database. And the dashboard also visualizes the time evolution of the current bids and asks the volumes by seconds. We also report big number charts shown on the right-hand side of the dashboard of the current total ask volume and the total bid volumes. Moreover, on this dashboard, we are visualizing the bid to ask volume by minutes and bid to ask ratio, which is calculated directly on the dashboard for the users. And all these metrics are coming from the depth database that is shared from MariaDB. Additionally, all these metrics can be filtered by account or crypto symbols, making it easier for the users to visualize the data he or she wants to see on the dashboard. And it should be considered and taken into point that this is a demo for ASME corporation use only, and it needs to be further evolved for personal users of for this dashboard. And we would like to thank ACME Corporation in trusting us with their new lines of business to create a real-time control center. And we look forward to working with them in the future. Thank you.